Welcome to On.NET, a weekly chat with the .NET team and guests. And today our guest is Mads Torgersen, who is... So I'll let Mads introduce himself. Go ahead.
Okay. Well, I'm the PM for the C# language. So my day job sort of is to keep the language evolving and try to put some nice new features in there on occasion. We're currently looking at the C# codename 7. Because the last one was 6, so that's how I think we are.
Yeah, I hear that a lot. I hear you say that it's a code name, that 7 is a code name. Really? Is it?
I don't know. I think that I'm just trying to joke a little about you never know what the next version is going to be called, but it's also, part of it is that we are looking at a bunch of features right now, probably many more than we can put in a single version. And rather than say that they are all targeted for a specific version of C#, by calling the whole project C# 7, that kind of allows us to work both on the short-term and the long-term features under that heading. So there's a little bit of that as well.
So it could be next or future or something like that. But
yeah.
Okay, so it's just a way of saying it won't necessarily all be in the next version.
It will. I will guarantee you that it will not all be in the next version.
Okay. Okay. Okay, I have a question in email from Nicola, and I'm trying to see where the question is because it's actually a long email and I don't see a question mark anywhere. Yeah, actually, I'll decipher it later because it doesn't seem to be actually directly C# related. So okay, so one of the things actually I wanted to ask you about is how do you think that C# compares today with the current landscape of languages? We see a lot of languages emerge. Some actually take off, some just die after a while. What does it look like today?
Right, so I think that's actually I think there's a super interesting and wonderful landscape of languages right now. We've gone out of the times where a few languages suck out all the air of the room and there's no room for little languages with new ideas to grow. Nowadays, a lot of languages are able to simultaneously not just gain an audience, but also gain attention way beyond their immediate audience of full-time developers. I don't know exactly what's happened, but it's certainly wonderful to see. One of the effects of it is that many more sort of paradigms or features or mindsets, if you will, actually get attention and become familiar to a broader set of developers, which also means that someone like me who is in charge of evolving a relatively old language, there's more freedom, if you will, to evolve in a direction that's useful and that brings in higher productivity features because people have more exposure to new ideas and are sort of more ready to accept new things than maybe was the case before. So I think it's a great time to be a language designer. Of course, I want my language to succeed, and so you might say, well, isn't more competition bad for us? But I think that it's a case of a tide that lifts all boats, if you will. I think we all become better for the diversity of ideas and the better possibilities to grow. So I'm a pretty happy camper in this landscape right now.
Is it really a new phenomenon though? Like if you think back 15 years ago or 20 years ago, you could say it was Java and then C#, and then fast forward a little bit further and it was Ruby, and now it's kind of maybe going Rust. Is it just like a continuum of a phenomenon that's existed for a while, or is it fundamentally different now?
I think there's always been lots of language innovation going on, but there's definitely been periods of time where it's been hard to break through. I think in particular at the sort of pinnacle of the Java craze, that's probably the the last time we really had a situation where you almost couldn't get heard if you weren't doing something in Java. I guess C# was a reaction to that in some sense, right? But I think that for some reason people seem to become more and more courageous about trying new things. Maybe, maybe in the startup business, people aren't so afraid of embarking with a new technology because they know that once they have to scale, or once they get the next 2 orders of magnitude of customers, if they succeed, they'll just rewrite it again in something that scales better or whatever. But so you don't expect necessarily your code base to live as long as maybe you did in the past, or at least there are segments where you don't. And so you can be more courageous about taking a bet on something, and then, hey, if it didn't work out, we'll just change later. And you see even relatively big businesses moving their code bases wholesale between different languages and different stacks as their needs change. So I think that's just more of a readiness to take a bet and try things out.
Do you think that there's like a kind of a chicken and egg aspect to what you're saying? It sounds like one of the things that has given voice to these new languages and new ideas is an openness to that. And someone at these companies who kind of approves this project of rewriting the whole stack, or someone has to approve that. So do you think that there's like a mind shift within these companies? Do you think that, I guess maybe it started in the startup world? Because there has to be a buyer to some degree. What do you think about that?
Do I think there's a mind shift in those companies?
Yeah.
Yeah, probably on average a little bit. I think that maybe it's not just a mind shift. I'm just thinking off the top of my head here, but there's also been a shift in what kinds of code people are developing. Right? There's a lot more apps or backends for apps that have a much shorter lifetime than maybe. There's certainly still enterprise code. There's plenty of enterprise code that has an expected lifetime of 20 years or whatever. But there's this new segment as well, things that are, built more on the off chance that it'll succeed, so you don't want to invest too much in it up front, and also that maybe has a shorter expected lifetime even if it does succeed. So it may not just be a shift in mentality, it may be a shift in the domains that are targeted, or the magnitude of those domains relative to each other.
Makes sense.
But I'm just speculating here. I don't have like hard data or something. I'm just enjoying whatever it is. I'm enjoying the fruits of it. I think that people are much more open to new ideas in the language space. And hey, great. That means we can put more great stuff in without scaring people away.
Okay, so speaking of that, and now I'm completely dark for some reason. Speaking of that, is there any feature from other languages that you are envious of?
That I'm envious of? I do get a little envious every time there's a new language that people fall in love with because it's so simple.
Yeah, because we can add, but you cannot remove stuff from the language now, right? So
C# used to be simple. It started out that way. Most languages start out simple. So one of the downsides of having had your language around for 15 years and having had sort of a moderate to high rate of evolution of that language is it's no longer simple. You can only add, you can't remove, or at least according to the philosophy that most of us apply when we evolve the languages we're in charge of, we want them to be backwards compatible. There are very notable exceptions to that philosophy actually out there. Probably the most the most sort of high-profile one is Python, which went through a breaking change in version some years ago, and with some negative consequences. It was, and And we're also seeing Swift today coming out from Apple, where there's a deliberate philosophy to say, hey, we'll learn from our mistakes and we will make breaking changes from time to time. But on the whole, so we'll see what happens with that. That it may be that in 5 or 10 years' time, we've sort of adopted a different philosophy of feeling more at liberty to do breaking changes to our languages. But for now, that's certainly not the way we're thinking about it in C#. And then we only have one option, and that is to grow the language. Sometimes we try to do it in as subtle a way as possible, like add a little keyword here and a bunch of semantics under the hood, so it doesn't change the language too much at a time, like we did with async or with dynamic. But on the whole, the language grows, the language spec gets thicker and thicker, and simplicity. You can still write simple code, but the language itself is no longer simple. And when I look at something like, actually Go has been around for quite a while, but it hasn't evolved so much since it came out. As actually a deliberate choice.
Yeah, they're saying that it's done.
They say that it's done. Let's see about that. Let's see if they can resist the temptation to add generics, and once they do, maybe they can't call themselves simple anymore. But for now, they've chosen to stay simple by not evolving, by claiming the language to be done, and that's a very powerful statement, because you can really learn the language and kind of expect that you know all you'll ever need. So I get a little envious of that sometimes.
What consequences does it have to say that you cannot break anything in the language? Does it have consequences in the way you design things, where maybe you put things that are less certain in the class library rather than in the language, and how do you manage that boundary between the language and the libraries, so that you avoid that problem of breaking the language in later versions?
Well, I think you're definitely onto something there. The desire not to break things means that we have a very high bar for including something in the language. Obviously, libraries also have to be around till the end of time, but it doesn't matter quite so much if occasionally, even as you maintain an old version of something, you also introduce a new version that has essentially the same domain but is a more modern design or whatever. In the language, you kind of expect people to be able to grasp the whole language, and so there we have to be really careful to add something. So it has a positive consequence, I think, that we really, really think carefully before we add something. It really has to earn its place in the language. It has to be something we want to have there forever, right? So that's a good thing. Yeah, on the negative side, the compatibility means that it can be hard to fit a new feature in, because there's so many other features already that weren't designed for that feature to be there, and so all the interactions, be they like syntactic clashes or just semantic subtleties coming out of the interactions between features, that makes it really, really hard, increasingly harder over time, to design features that are clean and kind of conceptually simple, while at the same time fitting in seamlessly with the existing language. So that's sort of the downside, if you will. That's where we kind of have to really put all our design skills to use.
So I have a follow-up question on that, which is, I know that subsetting the language would probably be terrifically difficult and have a bunch of downsides. That said, I wonder if there's like an opportunity for kind of soft subsetting. You know, like we have statement completion in Visual Studio, and there must be some kind of, you know, golden path set of features in C# that you're quite aware of, that you would say like, oh, I think these are the set of features that a new C# developer should be exposed to. They'll get a really good first experience. They won't get two features that kind of do the same thing but are different. Is there an opportunity to provide kind of a more limited, I shouldn't say limited, just more bespoke version of C# purely in the kind of IntelliSense statement completion world?
Yes, definitely. So technically, it's definitely possible. I would say doable. And actually, I think one of the benefits C# has over most languages out there right now, together with VB, is that it has the whole analyzers framework around it. So you could actually have, in addition to thinking about ways of opting into language limitations from IntelliSense, you could also have analyzers that will impose certain restrictions on yourself. I switch on an analyzer and it won't let me use dynamic. I switch on an analyzer and it will warn me whenever I implicitly box an integer. It all depends on, so you can certainly imagine that if you want, and I think we're starting to see that, if you want to limit yourself to a subset of the language or exclude certain features, it's easy to do so, especially using analyzers, and you can even do it yourself. I actually feel that there isn't a whole lot in the language that I would want to exclude at this point. I don't think, if I were to like subset the language, if I got that opportunity, there wasn't a whole lot that I would throw out. I think that the caution imposed on us by the requirement for backwards compatibility has kept us, by and large, on the straight and narrow. There are only a few things that would probably fall out if we had the chance.
Right, but what about maybe having determining a subset that we think is the best for people to learn, for example?
Yes. So it's more that you have a particular domain or objective that you want to subset the language for, language and the libraries maybe, or whatever. That I think there's a lot of opportunity in that, and we could certainly think about carving out a sub-language that's a good learning sandbox, if you will, where you learn fewer concepts and you still get the core of the language, and then you can graduate to advanced features at some point.
Yeah, and to follow up on what Rich was saying, maybe actually having the tooling evolve with you as you learn, where at first it exposes maybe on the top the things that you are most likely to be using as a beginner, and maybe more and more through the analyzers or through some other mechanism, it actually teaches you some additional techniques as you go. But
yeah, so there might be an opportunity there, and to be clear, analyzers will help you subset the language only in the sense that it'll tell you when you do something that the analyzer doesn't think you should do, but it doesn't integrate with IntelliSense or completion in the sense that it will prevent things from even showing up. That might be a next step to, I mean, we could investigate whether that's worth investing in, but that's not, analyzers don't do that today.
What they do is function as a teaching mechanism, where they don't just show you something that you should not do, they also tell you why and show you the solution to it.
Yes.
So that's very useful.
Yeah, they give you a fix as well. So I think I think analyzers are an interesting. We're sort of more. I guess we're more in the tooling kind of discussion right now. But actually, it's interesting that analyzers. It's an example of one of those things that sometimes there are things around a language that that are a benefit, even though they aren't actually part of the language itself. Sometimes there's a part of it's the tooling around it, or the situation, or the domain that help drive a language to popularity, for instance, or that become the real reason people invest in languages. Not always the inherent language features themselves. I think we shouldn't, as language designers, we shouldn't fool ourselves into thinking that the design work that we do is the only or most important part of what makes the language, that makes or breaks the language. There's so many other factors involved in that.
I have a different question, if we can maybe depart from this topic a little bit, just to provide more interest. So last time we had Mr. Mono, Miguel, on the show, which was a great topic. And as you know, like, Mono has a lot of affinity to Linux. And so, you know, with your Microsoft hat on, Mads, which isn't very difficult for you, that's so funny. What do you think about C# adoption, you know, in a completely different community? Like, so far, it's been we've had a particular audience, and I think this Linux one is a different audience. What do you think about the adoption prospects there for C#?
I think that it will be interesting to see, right? Of course, I have high hopes that C# is attractive to people, not just because of its affinity. We should soon say its past affinity to Windows, but because it's attractive in and of itself. Certainly, there aren't really things in the language itself that tie it to Windows. I think it's an excellent language for use in other platforms. The platform doesn't really matter to the quality of the language, I would say, and to be sure, that's why Mono is a thing, right? Mono became a thing because of the perception that C# would be great for targeting Mac or targeting Linux, and later targeting iOS and Android devices as well. So I think based on the success of the Mono project, there's good hope that C# will do fine in these other domains. Of course, there are cultural things where people just aren't used to even thinking of C# as an option. There are also there are, what can you say, like ecosystem things where C# has a strong ecosystem tied specifically to Windows, maybe, and not so much on other platforms yet. And so part of its success on those platforms would depend on to what extent that we can grow an ecosystem around it that's healthy. So that it's not just Microsoft providing tools for C# and for .NET, but that there's a third-party ecosystem that's healthy, and people can generally find the tools they need for the job. Right? That's a big factor in being even an option. Like some people have requirements that this, and that has to exist, or we won't even go there. And if we can't provide the basics, we're not even in the running for people to choose for a project. But given that we can be in the running for many people, I think we have a pretty good shot. I think what we try to do, and what feedback tells us that we're pretty successful is to be at the same time, you know, an evergreen language in the sense that it's been around for a while, and it's therefore kind of solid, and it's confirmed good by its success over the years, but at the same time being a language that is not afraid of modernizing itself and evolving to address current needs as they change for developers. So that brand has worked well for us in the domains we have had access to in the past, and I think it's a good angle to have on as we enter new markets, if you will, or new domains.
Makes sense. On that note, I've actually been surprised. We've had a bunch of companies approach us about, you know, a .NET Core story on Linux. Some of which were definitely unexpected for me. So one that has been public, so I can talk about it, is we've been working with Joyent. At the end of last year, they're looking at supporting .NET Core on their operating system, and they did a bunch of tweets about them. The engagement was entirely focused on performance, and so they were tweeting that they were actually fairly surprised and happy with the performance they were seeing. We made a couple of fixes for them, and that worked out. So I think, you know, that ecosystem, I mean, there definitely are ecosystem concerns like you raised, but it's happening faster than I would have expected. That's really positive.
Right. Yeah, I'm not like, it's not that I'm super concerned about it. I'm just saying that's a success criteria that needs to be there, and early signs are good on that.
Yeah.
We have some audience questions.
Awesome.
The first is from Gert. I hope I'm pronouncing this okay. Otherwise, I apologize. What are your thoughts about WebAssembly in relation to C# or future versions of C#?
WebAssembly.
It's like the next thing past ASM.js.
Yeah, that's a good question. I guess so. I haven't had many thoughts about it.
Before you answer, maybe we can describe what WebAssembly is for those in the audience who don't know.
Right. So, essentially, it's a. You can, I guess, Richard, correct me here if I'm not saying it right, but it's sort of like a compilation target, right? That would be a much more low level than JavaScript target that would apply across browsers and also a lot more performant. So it would be a desirable compilation target for other high-level languages like C#.
Yes, so the history of it is that, as Rich was saying, first there was ISM.js, which was a subset of JavaScript that was targeted at it was a subset that would create the possibility of optimizing the code, in particular with regards to memory allocation and stuff like that, to eliminate some of the things in JavaScript that create performance issues, in particular for games and stuff like that. So that was the first step, but it was still JavaScript running. And WebAssembly is kind of a second step in that, which is a kind of a virtual machine for target compilation, as you said. Yeah, that's probably the best way to describe it.
So I think that I mean, one of the things that you're seeing is that we are right now, and we touched on that before. We're right now broadening our set of compilation targets, if you will, very considerably, and actually, so both in terms of which platforms do we target, and also whether we target a virtual machine, the .NET runtime, or whether we compile to native. And I think so if we think about WebAssembly maybe as sort of a native compilation target, there's no reason we couldn't target that, or no reason that I know of, not knowing the technical details, why we couldn't target that as one of the machine architectures that we would do native compilation to. It's also possible that we could even stand up a full .NET runtime on top of WebAssembly, but I don't know if that's realistic. Another question, though, is whether it should be us, Microsoft, doing it, or whether that's a great project for someone else in the open source community to take on. As more and more of our assets become open, it might be an opportunity for someone else to go run with before we even get to it. That would be great to see.
And that would be a way to finally get C# in the browser.
Yeah, it'd be a way to get all the languages into the browser, maybe, if WebAssembly is adopted and it is good enough as a target. And those are things I don't know it well enough to assess either of those two. But if it takes off, that's actually going to be a bit of a. If it takes off, it could be a bit of a game changer in terms of JavaScript's monopoly in the browser.
Well, Unity actually has a bit of a proof case for C# in the browser. They, you may know, they have this IL2CPP technology, and then they have which, and the name suggests, produces textual C++, and then they use the Emscripten toolchain to produce ASM.js for both the C++ generated from IL, as well as for their actual Unity runtime. And I've played games in the browser based on that, and so that works. And so I think the fact that C# was able to target ASM.js is probably very suggestive that it would also work well for WebAssembly. I'm guessing that the WebAssembly designers looked at the ASM.js workloads and probably didn't leave too many of them on the cutting room floor. And I also agree with Mads that you know, we've got a ton that we're doing that only we can do, and that would seem like an amazing community project. It's definitely one that I think we would support and encourage. And I also agree that opening up the browser to more languages would be amazing. I think there are so many people that would be happy about that.
Right, and I think that a technology like WebAssembly that enables all languages to migrate onto the browser is probably a better way to go than specific languages trying to squeeze in and kind of get a duopoly together with JavaScript, right? This should be a matter of making the browser a platform for everyone. That would be a much more healthy thing to see in the market.
Yeah. Okay, so we have another question from Robert. Are there any language features that you want to implement in the future but currently can't because of limitations in the CLR?
Yeah, plenty.
Specifics, please.
Specifics. There are. Let me take one that's may seem like a small one, but that is particularly confounding right now. Many languages, Go for instance, have a great notion of slicing up arrays. Okay, where you get a slice when you have an array, you can take a slice of it, and what you get is a window onto that same memory. So any edits, any mutation through either of them will modify the same cells and be observed through the other one. And slices or full arrays, they're really the same thing, right? It's just a matter of two windows overlapping or subsuming each other onto the same memory.
Yeah, actually any API in Go that can take an array can also take a slice. They are really the same thing.
Right.
As far as the semantics are concerned.
I would really, really love that in C# because it's one of those things where people tend to get performance bottlenecks all the time with arrays because they accidentally or out of necessity they copy arrays around or copy parts of arrays out so they can use them with APIs that take arrays and so on. This is something that we could solve only in the CLR runtime. We would have to evolve the runtime to quite significantly in order to enable this. And any solution that is just language-based or compilation-based or even library-based is sort of is going to not quite cut it. It's going to have some significant downsides. Probably the most significant one is slices and arrays wouldn't be the same type. So any existing APIs that use arrays would be useless until somebody updates them to also have entry points for slices. That would just be a mess. So I would really, that's one that I really wish we could just do. And semantically, it's simple. It just requires very deep plumbing if we want to do it in the CLR. We haven't evolved the CLR from a sort of semantic viewpoint in terms of what is allowed in IL since generics, really. So getting to a point where we feel confident in doing that, even as we have all these different compilation targets that would need to come along, and B, doing the actual work to make the garbage collector handle all this and so on, that's daunting, and that's a shame. I wish it was simple, but it isn't. That's one example.
Is there a chance that it will happen anyway, even though it's very complicated?
Yeah, we're actively talking about it. I think it's one of those things that will have quite it's quite a long lead thing. We would both need to agree that we want to rev the CLR and get started on that and get to a point where we can push out CLR changes to all the targets at roughly the same time, and then if there are any language aspects to it, they will have to come along as well. So it's an operation on the same scale as when we did generics. So it'll take a while, but lots of us really want to do it. So if we get to where we can prioritize it and do the work, it'll happen. Yeah.
Okay. So Matt is asking, I've been reading Joe Duffy's blog post on the Midori project. Any thoughts on how Midori might influence C# and the .NET development model?
It already is in many ways. I think that we certainly have. I think we've certainly gotten more of a focus on performance issues, and we want to. The Midori project, just to update people who are listening in, the Midori project was an internal project. It was secret at the time, and Joe Duffy was one of the many people who worked on that project, and is now blogging about it in public, so people can start reaping some of the benefits of the project, which was eventually the project was ended. It was a big experiment, and it kind of ended, but. A big focus on it was to essentially make a systems programming language out of C#. Right? So take C# and keep adding things to it until it was a safe, efficient systems programming language. So that meant a bunch of and the whole stack would be replaced. Right? It wouldn't run on wasn't intended to run on the CLR. It was intended to compile all the way down, and intended to be efficient enough that we could build a whole. You could build a whole OS on it as well. Right? So that was the general direction of the experiment. And in order to make it safe and efficient, there was very, very heavy use of advanced type system magic, and to the extent I would say that it would probably be coding with that efficiently would probably be very, very strange and alienating to the majority of the C# user base today. So kind of wholesale adopting that strategy is not something that I think we could realistically do to C#. That would be taking a general purpose programming language and targeting it way too much to a particular corner at the expense of other things. That said, though, there are many great ideas in Midori, and we've looked at a lot of them in terms of how to evolve C#. We're starting to do a few things that Midori did. For instance, we're looking at some of that low-hanging fruit I was talking about before, where there are performance bottlenecks that tend to crop up naturally in C# code today. I mentioned the slices, which is one thing that Midori looked at. Another is that we're thinking about for the next version of C# is allowing ref returns, so you can return a reference to a struct, for instance. That's something that's a very low-hanging fruit that the CLR allows today, and that we could expose in the language. If you think about scenarios for that, Rich brought up Unity before, for instance. Game engines often have vast arrays of structs as the most efficient way of representing lots of game data. But the coding style around arrays of structs is really awkward today, because you can't reference a particular struct inside of the array and, for instance, return it from a helper function or stuff like that. So if I want to get that particular asteroid that's represented in my Space Aliens game and return that from a helper method, I can't actually do that without either copying it or returning, an index into the array or something. So being able to just reference structs and arrays, that would help game engines a lot, for instance. So that's one of the little things that we can just say, hey, great idea, let's do that. Also, if you look at the async feature, actually a lot of the optimizations that went into that, even as it got built, came from Midori as well. We didn't acknowledge it at the time because Midori was still secret, but a lot of what makes async sufficient or efficient in many of the common case scenarios is the thing that optimizes so that you don't heap allocate when there's no actual awaiting happening in a method, and all those kinds of things were all things that we could borrow from the earlier Midori implementation of async. So it's already influenced a lot, both in terms of design, in terms of implementation strategies, and in terms of mindset, and I think it will continue to do so.
There's actually another aspect that you didn't mention, which is from you said that the Midori project ended, which is true. But when that happened, actually, a large number of the people on that project came to the .NET team, to the languages team, and so naturally their brains were not wiped when that happened. They had all the experience that they developed, and I think also the people that went to work on that project, several of which who had been on the .NET or languages team before, had a bit of a different bias. And I think that bias was only kind of increased when they were in Midori. So when they came back, they've kind of been playing out their playbook on
Yes.
on Roslyn and on the runtime and on the libraries. Actually, if you look at GitHub, you'll see that all of a sudden there's like all this focus on non-allocating code paths for different methods. And that's all coming from those people. So, I think the experiment ended. I think a lot of conclusion came from that. But now, I think a bunch of it's being applied to the product, and hopefully that increases as a theme.
Yeah. No, I completely agree. I think it's in that sense it was, even though Midori didn't. A lot of people tend to think that if a research project doesn't end with a product with its name on it, then it's a failure or something. But I think Midori is an example of a very successful research project in that it influenced our products actually across the board, but .NET specifically very much so, both in terms of the people and in terms of the findings. So it's been very, very successful. There are many things that we couldn't have done if that project hadn't been going on. Yeah.
Yeah, and even that series of blog posts that Joe is writing is a part of that post-mortem
Yes.
process of extracting the useful lessons from the project. So, yeah. Robert is asking about, he says, I've read about non-nullable types, which is one of the features in the Csharp 7 codename project. But are you thinking about bringing some aspects of Csharp into Csharp, for instance, to complement the code contract API with syntax?
Yes, we've been talking about that some, about contract syntax, if you will, in the language. So Csharp, again, for people out there who don't know, it's actually, Csharp is a predecessor of the Midori Csharp. Csharp was MS research project coming out of MSR that had support for a lot more static analysis, a lot more verification, if you will, including syntax for expressing method contract. So you could have pre and post conditions. You can have a requires clause that says that this method will only run if the parameters fulfill these requirements. Then you can have an ensures clause that will then make checked guarantees about what comes out on the other end. Midori had the same thing, and we've been looking at whether we should add some version of that to C#. And I think it's still on our radar. We think it's a good idea. At least preconditions are a good idea of better expressing what you have on top of your method bodies anyway today, where you say, you spent the first couple of lines validating your arguments and throwing exceptions if they aren't right, null checking and all kinds of stuff. Might be nice if there was a slicker way of expressing that was more making it explicit that you were doing validating a contract, and would make it easier for tools to pick these contracts out and put them in documentation, and for static analyzers to pick up on it and check for consistency issues and so on. So we think that is probably a good idea, and so it is one of those things that we're looking at in the C# 7 codename 7 context. But my guess right now is that it's not going to rise to the top of the pile right now. It seems to be one that will slumber a little longer before it makes it into C#. So while it's in the C# 7 project, it's probably not going to be in C# 7. That's my guess right now. But we're not dismissive of it. It needs a little more bake time.
What's your favorite C# 7 feature? The one you feel is the most important, that should absolutely be in 7.
That's a good question. It's, that's a hard question to ask. There's some that I really love, so I'm not going to give you one favorite. I like pattern matching, and I like tuples. Those are some relatively big ticket features that I think will make code look much more straightforward and simple. The thing in particular, I like the combination of the two. I think we're getting to a place where you can declaratively, almost declaratively, describe dispatching over different shapes of data, and that's something that's pretty ugly and pretty imperative in C# today, because the sort of prevailing object-oriented paradigm, if you will, is that that kind of dispatch over shapes should happen by having a virtual method in the base class and overriding it with different functionality for the different shapes as expressed by derived classes. But I think increasingly, when you have data, you don't have the luxury of tinkering with the classes that describe that data. What you want instead is to describe that dispatch from the outside, and pattern matching is great for that. And tuples are just great for describing. They're great for creating balance between input and output of methods, which can have today multiple arguments but only one result. So those are ones that I think will make C# more delicious to program in, especially when you're dealing with data. But I like every feature that we're considering. Otherwise, we wouldn't. Right? We have so many. Well, we have so many features on the table, but the sort of top contenders are there because we all kind of get warm and fuzzy about them, and we'll just have to. Even between those, we'll probably have to pick and choose which ones go into the very next release, and hopefully more of them can stay on the table for subsequent releases, because we ain't ever done, I think.
So I think Topor is especially interesting because once it's in the language, it seems like it would have very deep implications in the way the base class library is designed. I mean, we have all those existing APIs that could actually be transformed and refactored with that new feature. For example, all the the try something methods look like they could completely go away with this. So how do we do that?
Okay, so two things there. First of all, we're having talked about it. We don't actually think that the try method. So most out parameters out parameters are the way of having extra outputs today, right? And they're ugly because they sit in the parameter list. However, most out parameters occur today in try methods, right? But try methods aren't actually a really great candidate for tuples, because the way you use a try method, the way you want to use a try method is for it to be called in an if condition or a while condition or something like that. And so you want it to just return a bool. If you had it return a tuple instead with the bool and a value coming out, then you'd have to pick it apart before you can have it sit in that if condition.
Well, you can actually deconstruct that and test it.
You could
for example, so you don't like the way Go is doing it?
What way is Go doing it?
For example, it's very common that a method would return a result and an error object. It's not exactly the same thing, but you would deconstruct that and use the error object in an if and do something else with the result if there is no error.
But the pain with try methods today is that you first have to declare a variable. But then at least you can call the try method directly in the if. You don't have to first have some kind of unconditional statement that calls the try method and deconstructs it. So the ideal would be if you didn't need any code before the if, but you could just do something inside of the if condition.
Yeah, and that's what they are doing. Actually, the if statement in Go enables you to have first an assignment and then the condition.
Right. So they tailor
very common pattern. So they included that into the if.
Yes. And that's one approach is to tailor your language around this, around tuples in that way. I think that, so actually for C# 6 we almost included, and then the final stages yanked a feature that we call declaration expressions, which allow you to introduce a variable and assign to it in the middle of an expression. And I think actually that, or some restricted version of that, specifically for out parameters, that would probably be a better match for the try cases. So so I actually think that the things in, if you look at the core libraries today, the things that use, because out parameters are so hideous, they aren't actually used much for multiple results. They're just used for the try pattern mostly. Instead, when people have multiple results, what they do is they introduce a type that's meant to carry the multiple values. So they actually declare a named class or struct or whatever to hold the tuple, if you will. So they make their own tuple type. Either that, or they use the framework. If they're relatively modern and they have the tuple type available to them in the framework, they use the framework tuple type, which means they have to give type arguments to tuple of this and this and this, and they have to construct the tuple and return it, and things get ugly in a different way. For instance,
and they have to do object.item1 and
yes,
ugliness.
Yes, and the consumption is also ugly. And so people have these different ways of working around it. Out parameters aren't actually used much in what encoded I see for that, because they're probably the worst of the bunch for most scenarios, except the try pattern. People use some kind of, they compose an object themselves and return that. And that is what we're going for with tuples, where you don't have to declare a type up front, you don't have to construct an object before you send it back. You have instead you have a syntactically lightweight thing that's comparable to what you do when you call a method.
So it's almost like an anonymous return type.
Yes, it is almost like that. And the idea is you should almost not even think of it as a type. You should think of it just as, hey, I'm returning these multiple things. And actually, the way we're thinking about the feature is similar to how Swift does it, where the members of the tuple can have names, so that when you get 3 strings back, you can actually dot in using those names, and you can see whether you can see whether which one is the first name, which one is the middle name, and which one is the last name, right? Instead of relying on documentation for such things. So yeah, it should create a lightweight experience, and in particular eliminate the need for explicitly declaring types or constructing tuples and then getting at them with item 1, item 2. It's that kind of scenario that we're trying to make better. But that doesn't, so that still goes to your other question, which is, what about APIs that already do use one of the heavy patterns, if you will, and should those be refactored? So that's I don't think we've thought about that so much yet. Like, what can you do with legacy code? That's a good question. So there are a couple of possibilities. One is,
it happened with async, right? So
with async, we just plowed through and said, here's another pattern. We already had 2 or 3 patterns in the BCL at the time, so we sort of language sanctioned a new one, and everyone just had to evolve for it. But the benefit there was so great that it was clear that you should evolve. And also, for most of those patterns, it was possible to add overloads next to what was already there that were task returning. I think the problem here is if you have a method that takes 3 arguments and returns my composite type here, you can't just introduce another overload because it would take the same argument.
Yeah.
So another thing that we could look at, and we haven't looked at so much yet, is there a way that you can take those existing types that people have declared and that they return and somehow make them tuples, in the sense that people can that you can add a specification of how do they decompose. And
so something like duck typing for return types or something like that, where if it looks like the shape that you used to return, but the consuming code takes a tuple, the compiler knows how to map it somehow?
Yeah, maybe if they can specify either how to be deconstructed or how to be converted to a tuple, maybe the consumption side can still be happy, can still deconstruct and be nice that way. So once you have that tuple deconstruction in the language, and pattern matching for that matter, maybe existing types can opt in to being easily consumed by that.
One tuple scenario that I've run into, or at least that it doesn't support, is IEnumerable. Like it has these, item 1, item 2, item 3. In some cases, they're all the same type, and you want to get at them in a particular order without having to go through the item 1, item 2, item 3 thing.
The new ECMAScript has a construct for that, where you can assign to an array what comes out of the enumeration.
Although it'd be nice to not have to copy it to the array.
Right. So TypeScript being a typed layer on top of an untyped runtime. In TypeScript, you're able to express either a tuple view or an array view on a given array. The array view lets you index all through the same type, and the tuple view lets you look at the array with different types for each element of a certain, viewing it with a certain size. I don't think we have that same luxury because we have a typed representation at runtime. But it's interesting whether there should be some way of iterating over the members of a tuple.
Presumably that would not be very difficult.
Well, I think the trick is what is the element type that you use for the iteration? How do you express that? Do we kind of type inference on finding the best common type for all the members, or like how do we do that? I'm not saying we can't do it. I'm just saying that's where the challenge probably is.
I understand. I mean, there's the simple case where they're all the same type. And then that's easy. Yeah, and you don't want it to always be object.
Right.
And maybe pattern matching can help you. We're almost out of time. Maybe we can take one last question from the audience. We have one from Robert again, which you're going to love. What is the status of async enumerables in C#? In ECMAScript, they are looking into using observable and async await syntax. Will C# do the same or something similar?
We are so async enumerables is one of the things we're looking at. We're proud to be the language that made async await popular. We came up with the keywords, and everybody's copying us, and yay! But other languages are now going a step further and supporting in the language async enumerations, if you will, where you have, or you can think about them as streams, or async collections, where multiple values that come at you asynchronously that you can consume in a kind of pool model. So imagine for eaching over one of these, and every time around, you would the for each would just asynchronously await the next element if it's not already available. So that's something that we think the language should support, and we are working on it. Will it be in the next version? I don't know. There's significant design work yet to be done there, but it's one of those that I am hopeful we'll start prototyping in a not too distant future and try to get a handle on. I think it's the right thing to do, and it's important.
How does it relate to reactive extensions?
How does it relate to reactive extensions? Well, so reactive extensions are a push model where you sign up. You essentially sign something up to get executed in an event-like manner whenever a thing comes at you. And I think async and the async enumerable we'd be thinking about is more of a pull model, And when you think about it, the difference is that when you have a push model, the producer of the values determines when code gets run, whereas in a pull model, you determine when you're ready to get an element and execute your code on it. And so there would have to be. So I think iObservable and reactive extensions are great for expressing how, expressing declaratively how you combine streams of events in various ways and filter them and do great things with them as where the streams themselves are objects. And then at the time where you want to consume a given stream that maybe comes out of all that, that's where you probably want to go pull based, and you want to make some policy decisions. So you probably want to adapt your iObservables to async enumerables, if you will, and you can make some policy decisions when you do it as to when I iterate over them, do I want to get all the elements that were ever fired at me, even if that was some time ago because I wasn't ready, or do I want to just get the latest one? Do I want to not even get the latest one, but only get the next one that comes, so it's always completely fresh when I go around? I think there are adaptation decisions there that may be well expressed in terms of how do you go from an iObservable to an iEnumerable, and having different methods for that, if you will. But we have to sort it out. We'd love to do it. Cool.
All right. So it's been an hour. Thanks a lot, Mads, for talking with us and enlightening us on the next version of Csharp. That was very, very interesting. Thanks, Rich. Next week, we will probably have some people from Unity joining us for a conversation. So we're very excited about that because we're all gamers, of course. So thanks, everyone, and we'll talk again next week.
Thank you. It was great.
Bye. Bye.